Okay, that's enough with those parent function transformations. I don't really like those, the way of doing that, but I went through it. So now I want you to look at this. Now, as you remember, okay, y equals 3x minus 2. Now I want you to put 3. You're not going to just put 9. That's not the answer, okay? So you're going to put 3, 2, 1, 0, negative 1, negative 2, negative 3. Now, put what y equals on the other side. 3x minus 2, 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 3x minus 2. So, I'm going to put a times dot here, and I'm going to replace the x with 3, because that's what's over there. Now, this is mental math. 3 times 3 is 9. 9 minus 2 is 7. This is not going to be negative 7, though. Okay, now put your 2 in. 3 times 2 is 6. 6 minus 2 is 4. 3 times 1 is 3, minus 2 is 1. 3 times 0 is 0. 0 minus 2 is negative 2. Now, this will not be 1 here because 3 times negative 2 is negative 5. 3 times negative 1 is negative 5. And then if I subtract 2, it's negative 5. I mean, that's negative 3. Take away 2 is negative 5. Okay. 3 times negative 2 is negative 6. Now, if you go negative 6 minus 2, you're at negative 8. Then 3 times negative 3 is negative 9. Minus 2 is negative 11. So, this goes in a line. As you can see, it starts high, okay? And then it goes down. Okay, if you graph that, it would be a straight line. That is why to graph these, when it's just x to the first power, you go m and b, the slope y-intercept. Okay. Now, and as you can see, the rate of change is 3. I mean, 3, 3, 3, 3, 3, 3. It changes by 3 units every single time. Now we're going to move this minus 2 out of here, and we're going to put a second power on the x. So this is going to be different. 3, 2, 1, 0, negative 1, negative 2, negative 3. Okay, so I'm going to write 3 times x to the second, same as I did here. Just write what the y equals. 3 times x to the second, because this is the expression that y equals in this equation. Now I'm going to replace the x with 3. Now before we multiply, we got to find out what 3 to the second is. So that's 3 times 3 to the second. Well, 3 to the second is 3 times 3. Okay, is what that is. That's 9. Okay, so it equals 3 times 9, and 3 times 9 equals 27. Now if I put 2 in for the x, now it's 3 times 2 to the second power. 2 to the second power is 2 times 2, that's 4. So we have 3 times 4, and that's 12. Okay, now I'll put 1 in. 3 times 1 to the second power. So 1 to the second power is 1 times 1. Okay, so it's 3. 1 times 1 is 1. 3 times 1 equals 3. Now I will put 0 in. Okay. So 3 times 0 to the second power. See this, I got to do some math because that's second power. 0 to the second power is 0 times 0, which is 0. 3 times 0 is 0. Now, put in negative 1. So 3 times negative 1 to the second power. So this is negative 1 times negative 1. What's a negative times a negative? It's a positive, so it's 3 times 1, which is 3. So you notice how this input, this output, and this output match? That's going to be a common thing here. So now I'll put negative 2 in for x. 3 times negative 2 to the second. Negative 2 times negative 2 is 4, so it's 3 times 4 equals 12. Oh, 12 and 12. What do you think this one's going to be? Look at the table. 0, 3, 3, 12, 12. Probably 27, okay? Now what's happening here? This is not a line, okay? You start high, then you dip down, and then you go up again. That's what makes that a parabola. Now, the middle part of this parabola is known as the vertex, okay? And this vertex is the point in the middle, the 0 and the 0. Now, what you're going to see on the back page are functions, okay? But there's an x second with an x, okay? When you see an x second, then an x of first power, you want to label that A, B, C, like you would if you had to solve, but instead of being equal to 0, it's equal to y. No. What you need to find is what the vertex is, okay? Now, if you remember, the vertex is that middle point, okay? There's a formula you need to know how to apply to find that, okay? Opposite of B divided by 2 times A, okay? So, write that down. This vertex is expressed as a coordinate. It's an xy coordinate. Opposite of B divided by 2 times A. So the opposite of negative 6 is positive 6, and then you don't make the A opposite. That's 2 times 3, and that's 6. 6 divided by 6 is 1. So 1, that's your x value. Okay, I'll put x equals. That's how you find your x. Now to find your y, you substitute 1 in for your x's. So you're going to make a parentheses, 3. Anytime you get to an x, make a parentheses and put 1 inside to the second. Minus 6, I got to another x, so I put a 1 and then plus 2. I'm going to substitute that into my calculator, okay? Because please excuse my dear Aunt Sally takes too long, mainly. Minus 6, 1, plus 2, and y equals negative 1. So that's your vertex in that equation. Okay, next problem. Vertex equals, you're finding the middle of the U. Okay, if I had to graph that, it would form a U. You need to know how to find the middle. Okay. So, the x is found with this formula up top. The opposite of b, just put OPP dot b divided by 2 times a. Okay, so a is 1, b is negative 6, c is 11. So the opposite of negative 6 is positive 6, and then I go 2 times 1. Well, 2 times 1 I figure out first, that's 2. Now I divide 6 by 2 and I get 3. So that's your x coordinate, okay? To find your y, this is your input. Now you put that input means you put it in for your x variables, both of them. So 1, when you come across your x, you make a parentheses and put 3, second power. Minus 6, 3 again, plus 11. Now you can figure out what the y is, okay? 1, 3 to the second, minus 6, 3, plus 11, 2. So 3, 2. That's your answer. Okay, next one, vertex. Okay, so this is A, this is B, this is C. The x in the vertex is equal to the opposite of B divided by 2 times A. So the opposite of positive 24 is negative 24. And then I do 2 times negative 3. We got to times that first. You got to find what's on the bottom. 2 times negative 3 is negative 6, and that equals 4. So 4 is your x vertex. Now to get your y, you simply replace the x variables, both of them, with this 4 value. Now instead of y being equal to negative 3x to the second plus 24x minus 22, it's y equals negative 3 times 4 to the second plus 24 times 4 minus 22. So I will just plug that into my calculator. 4. You can hit caret 2. The second power is right next to the 7 if you want to see the 2 actually go up. It's next to the 7. But that only works for second powers. Any other power, you got to go caret and then the power. Plus 24 and then 4 minus 22. And I got 26. Okay, vertex here. So A, B, okay? So x is equal to the opposite of b divided by 2 times a, okay? The opposite of positive 6 is negative 6, and then 2 times a is going to be 2 times 6. 2 times 6 is 12. Now I'm going to divide negative 6 by 12. It is not negative 2, it's a decimal, negative 0.5. Okay, now to find your y, you need to substitute negative 0.5 in for each of your x's. So 6 negative 0.5 to the second power plus 6 and then negative 0.5. Okay, that will find our y. So 6 negative 0.5 to the second plus 6 and then negative 0, just like I'm doing here. I'm exhibiting it, negative 1.5. Now these next two vertexes are found very quickly, okay? Now there's no b. A, and then it skips over the x term and it's c, okay? So I'm going to still apply opposite of b divided by 2 times a. Now if there is no b, then b would be 0. 0 doesn't really have an opposite, it's just 0. So then we would take 2 times negative 1, and that's negative 2. 0 divided by negative 2 is 0. So 0. Now I substitute 0 in for x, the only x I have. That will give me what y equals. 5. Okay. By the way, if you end up with x of 0, it's always going to be your c right there. Okay, vertex equals okay, so the x is found by opposite of b divided by 2 times a. Okay. Alright, so this is a, and then there's no b. Remember, it's ax second, then bx. Well, there's no x, and then c is your constant. So 0 is going to be your b, and then making it opposite doesn't really change the fact that it's 0. So 0, then 2 times a. 2 times 2 is 4. 0 divided by 4 is 0. So then we replace cx with 0. 2, quantity 0 to the second minus 12. Okay, so I directly substitute the 0, and then I'll find what y equals. So 2, 0 to the second minus 12 is going to be negative 12. Okay, now we're going to apply this to graphing. You're not going to be able to do the table with the 9, 1, 4, 1, 0, 1, 4. It's not going to work because you have an x term in there. So x second, anytime I see x second, I know it makes a u, okay? This graph, when I get it down, will make a u. Usually from now on with u's, I'm going to use 3 coordinates, okay? X, Y, X, Y, X, Y. The middle coordinate is where my vertex is at, okay? Now, label this A, B, C, and finding the middle right off the side, opposite of B, divided by 2 times a, okay? And that's how I find the middle x. So I take the opposite of plus 12, which is negative 12, and then 2 times 3. A is 3. That 2 is always there. 2 times 3 is 6, and then negative 12 divided by 6 is negative 2. That's your middle x. Now, you're wondering, how do you find the other x's? Well, you take your negative 2 and you add 1 and subtract 1, okay? So negative 2 plus 1 is negative 1, okay? There's your top x, and now you go back to your negative 2 and you subtract 1. That's negative 3. Okay, we got our x's. How do we get our y's? I mean, there's 3 of them. That's going to take a long time. No, it's not. Put parentheses around just your x's. Leave the second power outside. So, substitute negative 1 in for the x's. So we have 3. X is replaced with negative 1 in parentheses. close the parentheses and hit the second power key next to the 7. Keep typing. Plus 12, then I come across x again, and I will again put -1. Then plus 8. So I got -1 as my output. So when we input -1 in for the x's, we get a y output -1. Now don't clear the calculator. Don't clear it. Click the up key on your compass here, the up key. And now instead of -1, we want to put -2 here and here. So I want the negative sign still, so I go put the cursor over the 1 and hit 2. And where else did I put a 1? Right there. I want to keep the negative sign. And at the end, I'm -4. Now I want to put -3 in for the x's. So up, and get that cursor alive. So 3, 3. So now we're back to -1. Okay, so those are your XY coordinates. You can go by 1s on each of your axes, 1s by x's, 1s by y. So left 1 down 1. Left 2 down 4. Left 3 down 1. Okay, label your vertex point, -2, -4. And the domain range doesn't change. Domain is all because there's arrows on both ends. Okay, domain is possible values for x. I could put anything I want in for x, but then the output, the y. Okay, take that -4 right there. Put variable y -4. These numbers here are bigger than -4. -1's bigger than -4. So all the y's, it's going upward from there, so it's greater than or equal to -4. Okay, it's going up. See, look at compare the -4 with your other y's. Okay, -4 is less than the other numbers, so we don't want to eat the -4. We want to eat the y variable. It's greater than. Okay, next problem. You know you're going to need 3 coordinates when you see that x to the second power right there. Just mark the second power if the independent variable is to the second power, and that's the highest power you have. It makes this U shape. So this is your middle, the vertex. Okay. Okay, so we have A, we have B, we have C. So the vertex is the opposite of the B divided by 2 times A. Okay, 2 is always in that formula. So opposite of +4 is -4. And then 2 times A is 1. 2 times 1 is 2. Now -4 divided by 2 is -2. You divide these and it's -2. So that's your middle. Now to find these, you take your -2, you add and subtract 1. Okay? It's going to be the same thing as it was up here. It's not always that way. It just happened to be so. Now, put parentheses around your x's, and these are your inputs. Now you have to get your outputs. 1, -1 is my input. Close it. Second power, +4. -1 is my input again, but that one's not to the second power. Then I +4. So 1 is my output. Now don't clear the calculator. Click up. Now you just want -2 in place of the -1s. Now you want to do -2 as your input. And I got 0 as my output. And that's okay. Now I want -3. 1. By the way, this and this should match every time. Okay? This value and this value. So -1, 1. -2, 0, -3, 1. So -2, 0 is a x-intercept. Okay. Again, this is x, this is y. Okay, so your middle, -2, 0. Okay, so domains all, and the range you put y with your 0 value, because that's the middle y. And these are bigger, these other y's are bigger than 0, so it has to be greater than or equal to. Okay, next problem. Y is equal to 2x to the second power minus 6x plus 5. Okay, so it's a parabola. We make three coordinate XY points. And the middle is the most important point. That's the vertex. So, A, B, C, but there's a little formula that you use to find the middle x. Okay, right there next to it, I'm going to put opposite of B divided by 2 times A. So the opposite of negative 6 is positive 6. Now when you're doing this, don't put x's in there, just the numbers, okay? Then 2 times A, the 2's always there, and then A also happens to be 2. So 2 times 2 is 4, and 6 divided by 4 is 1.5. So 1.5 plus minus. Now you can actually add any number to this and subtract as long as it's the same number. I usually just pick 1. Okay, you could also do 2 or 3 or whatever, but 1 keeps you kind of on the straight and narrow. So I'm going to take 1.5 plus 1, that's 2.5. And then I will be taking 1.5 minus 1, and that's 0.5. Those are your inputs. Now to get your outputs, you input them in for x. So 2, and then 2.5 to the second, minus 6, 2.5, plus 5. I got 2.5. That's 2.5. Now click up. Now we want 1.5. So I want the 0.5 still. I just want to make it 1. See what I'm doing here? Okay. 1. And I'm good. So, wait a second, I didn't do that right. Now I want 1.5. 0.5, and now we're going to put, now I want 0.5 in for the x's. So I want the 1 replaced with 0, but I still want the 0.5. And then 2.5. So I know this is right because this and this match. Now, 0.5s go halfway. So this is x, this is y. So 2.5, 2.5. 1, 2, 2.5, 1, 2, and then 0.5. 1.5, 0.5. 0.5 is just right in the middle. Okay, you're in the middle. 0.5, 2.5. So 0.5 is halfway to 1. 2.5 is 1, 2, halfway to 3. Okay. Okay, label the x vertex, please. 1.50, it's always that middle. Okay, 1.5, 0.5, because that's your vertex. Domain is still all. Now we put y with that 0.5 value. 2.5, is that greater than or less than 0.5? It's greater than, so it eats the y. Okay. All right, last one. Y equals, two more. Y equals negative 2x to the second plus 6. Okay. This is a u because of the x to the second. Now, we're going to make our 3 coordinates, but this one's a little bit odd because I have an A. I don't have a B, okay? I don't have a B. This is a C, okay? Because there's no x. Now, so I can't really do opposite of B divided by 2 times A, but you can. If B's not there, it's 0. So I don't need to make 0 opposite, then I'll replace the A with negative 2. So B's not there, it's 0. 2 times negative 2 is negative 4. 0 divided by negative 4 is 0. By the way, if B's not there, then your vertex is 0 for x. Now you take 0 plus and minus 1. So 0 plus 1 is 1. 0 minus 1 is negative 1. Now, this is the only x I have, so I substitute 1 in. So negative 2, 1 substitution, plus 6. I got 4. Now I click up and do a substitution for 0. 6. Okay. Click up. Now you got, if you don't have a negative and you need a negative, you'll unfortunately have to clear it. So negative 2, negative 1 to the second, plus 6, and I'm at 4. Okay. Okay, so this is x, this is y. So 1, 1, 2, 3, 4, 0, 6, 1, 2, 3, 4, 5, 6, then 1, 1, 2, 3, 4. Okay. Now it goes upside down, and that's going to happen anytime the A is a negative. Okay. A is negative, it's going upside down. So 0, 6. Okay. So domain is all. Now put your y with its 6 value. Now look at the other y's. They're now less than 6. Okay? 4 is less than 6, so less than or equal to. Okay, then our last one. This is a little bit different. Y equals negative 2x plus 4. Well, this is quick because it's not a u. The x is not to the second power. There's no a. Okay? If there's no a value, it'd be a b and a c, which is just a line. Okay? Well, line, make sure the y is by itself, and label your MB. So that's slope and y-intercept. So negative 2 over 1 and positive 4. So on the y-axis, we go 1, 2, 3, 4. Then every time we increase by 1, we drop 2. So you can go 1 down 2, or you can go down 2, 1. It doesn't really matter. Okay? But every time the x would increase by 1, we'd multiply it by a negative 2 factor, and it drops the value of y by 2 from the 4. Okay? Now, this is just a line, and you're like, well, what do I do about the domain and range? Nothing. Okay? They don't exist now. Well, they do, but they're both all. They're infinite.